In this video, I'll be creating an asynchronous counter and an synchronous counter. So first, I'm going to start with asynchronous. And the first thing I want to do, I want to make a binary 16-bit counter, by the way. And by 16-bit, I actually meant 4-bit. It'll be a counter that counts up to 16. Well, it'll be up to 15. 0 to 15, 16 digits. As fun as a 16-bit counter might be. First thing I want to do is take a toggle flip-flop. I'm going to need 4 of those, one for each of my binary digits. So now I have my 4 T flip-flops, and I already wired them up, the outputs to each of the little binary probes. So now I have my clock and this 5 volt here. So since this is an asynchronous counter, the clock is only going to link up to this first flip-flop in line. Then for this 5 volt, I'm actually going to connect that to each and every toggle input on each flip-flop. So now I have my 5 volt high value going into all of the toggles on our flip-flops. And the reason I always have it on high value is because we always want, whenever the flip-flop updates, since we're doing a binary counter, it's always going to go from 1 to 0 or 0 to 1. So we always want it on toggle. Then I went ahead and included the little clear value here. And now we just have to wire up our clock inputs for each of these subsequent flip-flops. And in order to do that, I'm going to take just the output from each flip-flop that was previously in line and put it in for the next clock. Now we have our finished binary 4-bit counter. So for every clock pulse, the least significant bit being down here and the most significant here, it counts up. And we'll do this all the way to 16. So now we can modify this existing circuit to create our asynchronous counter. Sorry, this one is the asynchronous, so now we can modify this one to create the synchronous counter. Yep. Now I've deleted most of the things we had before for the asynchronous counter, but for the synchronous counter, we're going to keep our 4 T flip-flops, our clear and our clock value, as well as our little outputs here. And the first thing I'm going to do is, instead of having the clock going to just the first flip-flop, I'm going to connect it to each flip-flop, hence the synchronous. So now we have our clock hooked up for every flip-flop, and since we have that, every flip-flop is going to want to update whenever the clock changes. But we don't want every bit toggling every single clock cycle, so we're going to have to change these 5 volt inputs on the toggle to only toggle when we want them to. So in other words, if we want this second flip-flop to toggle, we're going to want it to toggle only when this one is going from 1 to 0. Because if we're going from 1 to 0, then we want this to display 1, so it'll be binary 2. So using this AND gate and enable switch, we can tell our flip-flops when we want them to toggle. So we have the enable going into the toggle flip-flop or the toggle input for this first flip-flop, because the least significant bit, that's going to be changing every cycle, no matter what the other ones are. And then for the second one, well, we have our enable set to high to ensure that the circuit's running, so that 1 is going into the AND. And then if this is outputting a 1, then that's also going into the AND. And so then this is receiving the instruction to toggle, and that next cycle, this will turn to 0 and this will toggle. So it's exactly what we want. And we can just repeat this kind of pattern for each toggle going to down. Now we have the logic in place for all of our flip-flops, and our circuit is completed. The enable switch, we're only running into this first AND. For the second one and the third one, we're just going to run the previous AND output into the next input. Because if we're getting a 1 from here, then we know that this number is toggling. But we don't want this next number to toggle if this is going from, say, 0 to 1. If this is going from 0 to 1, we want this to just stay the same. But if this is going from 1 to 0, then this will receive a 1 and a 1, and we want this one to change. So we'll receive the toggle input. And we can see here that we can successfully count up to 16.